New Delhi, hosted by Department of Mechanical Engineering, Mite. I am privileged to introduce the resource person, Dr. Deepak Paul. Deepak Paul received the MSc degree in Automotive Systems Engineering from the University of Michigan, Dearborn, USA in 2007. His PhD degree in Automotive Mechatronics from the Advanced Vehicle Engineering Center, Cranfield University, UK. Its research focus has been plug-in hybrid vehicles and battery electric vehicle development of different electrified powertrain topologies. His research during PhD was part of the Innovate UK grant that was led by Jaguar Land Rover UK for the electrification of JLR Evoque SUVs. He has worked on vehicle electrification research projects funded by the European Union grants from EPSRC. He has also worked on research projects funded by Government of India with academia on swappable battery and energy efficient drives for hybrid and electric vehicles. He was with Bosch and Whiston for over 15 years, where he was involved in the development of automotive powertrain, body control, and cockpit electronics products. His interests include electrified powertrain, vehicle dynamics and control, and regenerative braking for electrified vehicle. He is currently a principal engineer with Mahindra Research Valley in Chennai and heads the advanced vehicle electrification and controls the group in piloting vehicle electrification program of the automotive and farm sectors. With this, I request Dr. Deepak Paul to take over the session. Over to you, sir.
Thank you again for the intro.
Okay.
I'll just share my screen. Can you
Yeah, I will
go
stop my
through this?
presenting. Yeah, you can share now, sir.
Yes. You're able to see my screen?
Yes, sir, it is visible.
Okay. So, why is it I'm not able to see the screen? Sorry for that. This thing, again, I'm not able to see the presentation that is coming up.
Sir,
Are you guys able to see?
yeah, we can see that, sir. Make it full screen and you can switch to over to the presentation, sir. You can able to see that also.
How do I switch to the presentation?
Sir, F5 or there is an uh, you can go to that slideshow, sir. In the menu bar, you have that slideshow.
Okay, I will see that.
So in the PPT itself, are you able to see the
Yeah, I
PPT,
did
sir?
that.
Ah, sir, you can check with Alt tab. When you press that, you will get the
Okay.
multiple screen. So select that particular PPT screen, sir. You are able to view that.
I think I have a problem. It's not.
So when you press Alt tab, are you able to see the multiple windows in your laptop?
I'll do one thing. I'll put all my.
Or else, Aveen, you can do one thing. You can receive the PPT content from professor. You can present on behalf of him, then he can deliver.
Okay, sir. So we can do that, sir. If you mail me the PPT, I will
It's
present from my
quite
end.
big. What I'll do is I'm able to see it in the normal PPT mode, not in the presenting mode. I don't know why. I'm,
Sir,
you're able to see my screen?
yes, sir. I'm able to see the screen.
Yeah, but it is not in presenting mode. I'm not able to see it. I don't know. Will this be fine if you can see this?
Yes, sir. I think, sir, Rajsekhar, sir, is it fine, sir?
It's good.
Yeah.
No
Yeah,
problem.
fine. So I'll just proceed with this instead of letting you guys wait for.
Yeah, it's fine, sir.
Yeah, I think this should be fine.
Yes, sir.
Okay.
Yes, sir.
Yeah, so good morning. So my name is Deepak, and thanks for the uh, introduction, Aveen, and thanks for inviting me for this, what we say, faculty development program. And I'm so glad to see a lot of youngsters and the whole, what we say, this thing, academia folks from your end. So it's really refreshing for us to talk once in a while to very this thing intelligent and young people. So yeah, so I work for the Mahindra, what's the Research Valley, and I head this advanced vehicle electrification controls, a team which does yeah, piloting work on emerging technologies like hybrid and electric vehicles before it's put into a full-fledged program. So that's my team's role. It's a very small team. It's a niche team which works on that. And my research focus has been on hybrids and electric vehicles. So I'll talk to you this in today about sustainable solutions in hybrid vehicles. That is basically pertaining to the this energy management. So what I'll do is I'll just take you through a brief introduction of the hybrid vehicles, the market trend and all those stuff, and then talk about what kind of efficiency improvement that we're looking at, and then get into some kind of details of the what is the components in the this electrified powertrains in general, which might encompass both hybrid and electric vehicles. And then look at what kind of energy management strategies are possible. And once we've done that, what I'll do is we'll talk about what are the general challenges that we have in the this thing electric vehicle migration, and then I'll do a small comparison of what are the key differences between this thing hybrid vehicle and this thing electric vehicle. And finally, to conclude, I will just tell you the summary of it. Okay, so after which I think we can have a question and answer. Is that fine,
Yes,
Avin?
sir. Yes, sir.
Okay, great. So yeah, so the market trends, as you know, have been moving towards some kind of electric vehicles, and of late, many people are talking about EVs and yeah, battery operated vehicles. So the forecast, which is continuously being done by some of the premier groups in the world, one of which is the Boston Consulting Group. So they have projected that by 2030, we'll have around 30 to 35% of vehicles which will run hybrid powertrains, and around 20 uh, what to say percent of the vehicles which will run electric powertrains. So that's how it's been. So that shows that there is a trend in which the a pure uh, what, what what say the conventional powertrains are going to reduce their share, and that's going to come down to around 50%, and the rest is going to be uh, yeah, driven by some kind of electric powertrain. So that's the takeaway from this uh, what's a study which we have. And with respect to India, we have seen that the market is slowly and gradually moving towards battery operated vehicles and EVs. And of course, for now, the trend is mostly on the two wheelers and the three wheelers. And you would have seen plenty of three wheelers, yeah, yeah, running, which is purely on batteries, and also two wheelers, which is coming up. Plenty of what say this OEMs are making two wheelers. That includes TVS, Bajaj, and all the Premier and Hero and all the known what what is it two-wheeler brands. So that is where we are, and for now it's mostly on the um, unorganized sector. So the um, uh, electrification is basically moving to the unorganized sector. So that is what is actually driving the whole electrification in India. And uh, up to a speed of 25 kilometers per hour, we do not need any kind of homologation or maybe government approval. So all the low speed vehicles will not need any kind of maybe certification and homologation requirements. So, so it's mostly the unorganized sector which is driving the this EV sales. So, having said that, what is the motivation now? Why why are we moving towards uh, what do you say something known as uh, maybe zero emission free vehicles? Maybe left to ourselves, humankind will not do it. See, unless yeah, we are forced into doing it. We not really do something which might be very fruitful in the longer run, right? So that being the case, um, there are some policy that is which gives a lot of incentives, and there are also regulations which says that yes, you have to comply with this. So one such policy from the Niti Aayog is that we have to move by 2030 to zero emission vehicles, which is quite ambitious. But uh, even if we fulfill that maybe directive or guideline by yeah to maybe 50%, we'll do a lot of service to our future generations. So that is the whole what we say takeaway from it. And this started in 2017, which was phased into three phases, and they called it notching the um, arrow, drawing the bow, and letting the arrow fly. So we are in the second phase where we are actually drawing the bow, and we will let it go in 23, and hopefully that will fly after that. So that's the policy of the Niti Aayog, uh, which finally will lead to zero emission vehicles, but may not be zero emission, at least a low, what to say, carbon emission yeah, vehicles. So that is the policy which the government has framed. Now, Now, regulations are mandatory for uh, any this thing OEM to sell vehicles. Okay, so there is a regulation which is coming up, which is known as CAFE, and it is expanded as Corporate Average Fuel Economy. Now, now CAFE makes it very difficult for manufacturers like Mahindra to sell uh, what is a conventional uh, what is a vehicle, because we are mostly into diesel vehicles, the big vehicles, the more what is a rugged off-roaders and all these things. Star is one example of that, which you would have seen. So there are plenty of vehicles in our buffet, which are basically are kind of guzzlers of your fuel, and they're quite big, and they rely on the diesel what's it, combustion engines, right? So what the government is doing is to uh, to maybe as a corporate fleet, uh, yeah, they are setting the guidelines saying that you have to have a fuel efficiency of maybe 20 kilometers per liter for a weight category of around 1000 or 1100, and maybe 20 maybe 22 for a weight category of 1200. So that once the fuel economy is better, uh, what happens is our uh, emissions automatically come down. So that is the moot idea of this, and in order to meet this, it's becoming very difficult. And the number of vehicles which give in the excess of maybe 20 or 25, right? So there are very few vehicles which return this in fuel efficiency of around 20 to 25, right? So this calls for some kind of electrification which will improve the fuel economy. So that is one of the what do you say, motivations, or the chief motivations behind going for this um, electrification or hybridization. And along with that, the government has not really kept quiet and said that you have to comply and all this. See, apart from giving policies and regulations, they've also um, um, what we say expanded the uh, uh, what say horizons by saying that you will receive some kind of subsidy. So why should the customers pay more uh, in order for the government to make the this thing environment cleaner? So that being the this thing idea, they are subsidizing on maybe the this thing hybrid and electric vehicles. So yeah, subsidies were different for the last 5 years, and they're basically changing, and and mostly driven by the manufacturers, the way they are going to size their batteries and all of those. And one example of that is um, the 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 suppliers of batteries, or the maybe per kilowatt hour of battery capacity, we get a subsidy of around 10,000 rupees, which can be transferred to the customers. So this is one example of it, and these three facets actually guide us into doing more of electrification and hybridization. Now, now the next part of my talk, what I wanted to do was to give you a introduction of the benefits of electrification, and basically just to highlight what is electrification per se. So you might have had plenty of sessions on this. Just to recap on this, you have the conventional vehicles. In this picture, you see on the left that you have this engine and a transmission, and you have the red color roads a fuel, which is yeah, basically diesel and maybe petrol. And in the middle, you see is a hybrid where you have a motor and you also have a battery, right? So you have a battery driven powertrain, and on the right you see a purely battery driven uh, maybe layout for a vehicle. So you have three types of a vehicle, and hybrid is somewhere in between. It has it's a confluence of both the uh, sides. And you're talking about this thing efficiency. We all know that our IC engines are around 30 to 35% efficient, right? So you have plenty of losses. So as what we say, general maybe thumb rule or maybe this thing averaging, if we consider that our loss in the this thing engine is around 30%, right? Or the loss on the engine is around 70%, right? So we stand to have this thing overall efficiency of around maybe 30% from the this thing engine, and we have plenty of uh, maybe accessory power which is required. Maybe if we listen to music, we have the this thing, air conditioner and all this stuff, which take around 8% of the what we say this thing, energy. And we have the drive line which is also prone to losses, which is basically a transmission, the gearbox, and the differential, right? So that takes away another 3%. So what we are left at the end of the day is around 19 to 20% of this thing efficiency, which is pretty dismal if you look at it from a system level, right? So yeah, we this thing always have a band of this thing efficiency. Maybe you look at some of the best engines, the lightest vehicle, and what best they can throw out is a 30%. So that is the it's a basic what is it? This thing efficiency that we draw. That is for 1 liter of petrol or diesel that we fuel. 70% of that energy is being wasted, and that's very stunning, right? So that is one part. And what we will get out of this hybrid is basically uh, what we do is we try to this eliminate the what we say accessory power and all these things while the vehicle is maybe standing in a signal. We switch it off, and then they call it the start stop and all this, right? So we try to do that, and we try to maybe reduce the loss. And what happens in a full hybrid and all this is we kind of downsize the uh, your what's a conventional engine, because you will not need that big a size of engine, maybe at all conditions, right? So if we have this motor to assist the power and to supplement the what to say this engine power. So we downsize the a kind of engine and try to do little of decoupling, clutching of the this engine, to the wheel and all these things through clutches. And by doing that, we gain a little power, I mean, maybe a little more efficiency, and then there is another concept known as regenerative braking, which actually which actually can produce maybe depending on the component size, it can produce 2 to 6% or sometimes around 8% if the motor is bigger or the generator is bigger, if you have a bigger battery. So with all this, we can see a 8 to 14% of improvement in the this thing efficiency. Uh, and this is over the this thing IC engines. Now, suppose we drive the vehicle in a pure electric mode, which is possible in most of the hybrids, right? We would have seen plenty of hybrids, like not plenty in India, of course, like the this thing Volvo, and more recently the P300E from the Jaguar Land Rover, which I was working while I was in the UK. So we have certain maybe a few plug-in hybrids which have come to this in India. So say we drive the vehicle in what's a pure electric mode. So that is as an average, if we see this in Indian maybe car user uses the vehicle for around 30 to 35 kilometers a day to commute from home to office or whatever. So with that in mind, if a plug-in hybrid is capable of giving around maybe 30 to 50 kilometers as a range, as a pure electric range, we'd have something like this, wherein we have what is a battery operated vehicle, while our maybe this thing IC engine is off. We can run the vehicle in pure electric mode, and we kind of know that the motor's this thing efficiency is quite high. It's around 90% efficient, right? So your loss is only around 10% there, and as a result, we'd see around a throughput of around 80% as a what's it, this is overall efficiency. So we we can say that we might have the best of both the worlds. That is, while being while using it for maybe local city use, we can operate the vehicle in a pure electric mode, and while going on a highway, we can use it in a combined mode, maybe a hybrid mode. So that's one configuration. There is another configuration where we do away with the transmission, which of course is not there. Very few vehicles in the world have that, but it's a work in progress. The Polestar and which is another this Volvo based sedan. So that had that in the previous generation. So that is one example of this thing. So yeah, you could stand to have this energy improvement of around 60%. Now, I'd want you to have this in mind when we do this thing overall comparison between a EV and maybe hybrid, right? So have this in mind that we're going to have a 10% improvement or 10 to 14%, yeah, maybe this 8 to 14% improvement in efficiency from a hybrid. Yeah, so you just park this in your mind so that you are triggered when the appropriate slide comes. So as as a maybe as a category wise, when we say what a hybrid is, we can say that the vehicle is a micro hybrid, right? See, micro hybrid is something which just switch off the engine when you don't need it, when you're parked in a signal, when you're waiting in a signal. So it has a start stop. And the mild hybrid is something which can have a regenerative braking, though it might not add on to the whole performance or the power of the engine. It just maybe recuperates the what's it braking energy and gives it back to the battery so that it can be used for accessory power and all these stuff, right? And that also reduces the use of alternator, which again is a load on the engine. And we have the full hybrid, which does almost everything except charging from a wall unit. And the plug-in what's a hybrid is a combination of a conventional car and a battery electric a vehicle. So just imagine half of the vehicle is conventional and half of the vehicle is maybe electric. So I'd call it being a hybrid person. I would call it the best of both the worlds, but it's quite debatable. People debate it anyway. So yeah, plug-in hybrids can be charged from the what is a wall unit, and the battery's capacity will be slightly bigger, or even largely bigger than a full hybrid um, uh, maybe configuration. And you have another kind of hybrid known as a series hybrid, wherein we have this IC engine which actually charges the battery while the power is being delivered entirely by the motor. So one example of that is the BMW i3 Rex range extender that is called as. But this again classified as a hybrid, though sometimes it is mistaken to be this thing EV. And of course, the full electric that we all know, you might have heard a lot of that. Now, yeah, this is the this thing overall what we say topology. As you see, in a mild hybrid, you have this thing engine doing all the work, and you have a small generator and a motor which actually either gives little of assist and maybe charges the battery to some extent. So some kind of uh, energy is recovered and some kind of assist is given. And the series, your parallel hybrid is both the powertrains can provide a power to the wheels. So independently, it will be able to give, and also they can work together. So that is one. And the series hybrid is, of course, something like a battery electric vehicle, which is on the rear being what is it charged yeah, through a small engine, which runs in the most efficient maybe operating points in the BSFC. So this is in a kind advantages, but we don't have too many of those vehicles because you don't you'll need a very big say motor, and it's almost the cost of the this thing EV, and the cost is quite high. And the series parallel hybrid is it's a gold standard in hybrids, wherein you can do what is the power delivery through any of the powertrains, whether a conventional IC or the this thing EV, or the motor, and you can charge through the engine. You can charge through the what we say through the motor itself through braking, and at the same time you can also extend it to be charged from the wall unit. So you can make it a plug-in hybrid also. Not that you cannot make this thing others plug-in hybrid, but of course this makes the best sense, and most of the plug-in hybrids are series parallel hybrids. And yeah, so as I told you, there are multiple, let's say, hybrid configurations. You can see here that on the left in this picture, you will find that you have this P0 hybrid, which is normally the belt-driven, yeah, yeah, starter motor, and this is there in some of the vehicles. I think the Maruti's um, uh, Maruti's Ertiga and all those vehicles have it. Uh, the what's a belt driven BSG, and this is basically you have a belt which connects a small motor to the a kind of which replaces the starter motor, and that kind of generates some kind of power back, which will be little bigger than the what's a conventional starter motor and the alternator. So we'll eliminate the starter as well as the what we say yeah, the starter motor as well as the alternator. So you save on the parts, and also at the same time you get better what we say this energy back into the battery. So this is a very mild form of what's a hybrid. The second is this thing ISG, wherein it is mounted directly to the crank of the motor, and maybe through gear, maybe through some kind of maybe gearing and transmission. But it's not a full-fledged, what we say, this thing, not a very strong hybrid. The third is the P2 hybrid, which is where the motor is somewhere on the shaft itself, in between the gear box, that is the transmission, and the engine. And you will find the two sets of clutches, which will actually be on and off depending on whichever modes you want. If you want a pure this EV mode, you'll have the engine disconnected through the first clutch. Uh, Here you see in the figure in the left, in the top, and you have the this other clutch on. So this will connect it to the what's a transmission. And say you want to have both the powertrains on, then both the clutches will be on. So that is how a P2 works. Now, the P0, P1, and P2 are known as the pre-transmission. So you have the motors before the transmission, and the P3 is after the transmission. So that's known as the post-transmission, and it's just before the differential or the final drive, right? So a P3 is also quite similar, but it's quite expensive because um, you will need a separate kind of transmission for the motor, because you have to match the motor speed and the torque at the wheels. And there is another what is a configuration which I'll say is a very good configuration with a complete independent rear axle drive. They call it ERAD, and that is categorized as a P4 hybrid. So this is the P4 hybrid where the motor is there. Okay, so these are the basic configurations. The value, of course, we discussed. We get maybe the same, maybe some kind of additional power. We don't have range anxiety, and we have a lot of other benefits. And yeah, we came across this in the this in earlier slides, that for the P4 hybrid, we can have some kind of separate, what we say, maybe motor in a different axle to drive it. And yeah, we call it P4 and P5 hybrids. But these are basically, it can in a way function as a pure electric vehicle also, because it's completely independent. And it's also known as that maybe through the road, or what say a hybrid, because it's not connected to the front. So it's connected through the road. And of course, axle driven powertrains are gaining a lot of significance, wherein both the powertrains are absolutely the same independent, and they're cheap, and a kind of the cost is much lesser, because you don't need clutches and all this to handle it. You just have a single speed transmission, and it's put directly to the maybe the differential at the rear. An in-wheel motor is of course good, but I'm not a big fan of it, because it increases the um, unsprung mass, and as a result of that, the ride becomes a little poorer. But this is gaining significance because you kind of eliminate the transmission losses, and and the packaging is quite simple in this. Uh, some of our this thing two-wheelers have the this thing in-wheel motors, which of course you would see in some of the what is it, two-wheelers. So this is quite popular in the two-wheelers. but four-wheelers it is just coming up. So that's about the brief kind of introduction about the what is a hybrid in general. And what I will do in the next 20 minutes is jump into more details of the maybe the energy management, which is the prime objective of this, to give you this introduction and to actually challenge this group that uh, there's plenty of work to be done there. So in order to do that, I'll just give you this overall maybe what is a component list, which is very similar to this electric vehicle. You have the motor, you have a motor controller, that is a driver, inverter, and all this. You have a full lot of electronics, which I think you need not worry about, being more focused to a mechanical testing engineering department. So all you need to be concerned about is the motor, which is a device again like an engine, which gives power, which is basically torque times omega, right? Torque and speed, right? And you have the this IC engine, both working in tandem. Okay, so you have certain parts, and in the blue, you will see that there is a plenty of software and algorithm there. So you could forget about the hardware, which is you have basically the LOs. I will more focus on the software, wherein maybe the domain knowledge of the vehicle and the physics of the dynamics, maybe the physics and the dynamics of the vehicle will play a part in actually doing the algorithms for it. So, in terms of this, I'd actually told you previously that you mark that figure of 10 to 14%, right? 8 to 14%. So, in terms of energy, this thing equivalence, why would we uh, want a battery? Uh, we, yeah, from this slide, you can see that maybe the petrol or the gasoline that it's called is a gold standard in what's the fuels. It is so packed with what's say this thing, energy, that it is extremely highly what do we say this thing has a very high specific energy and a very high this thing energy density. 1 liter of a petrol will will weigh less than a kg, and it has a energy this thing equivalent of around 12 kilowatts at 12 kilowatt hour, so which is enormous, right? And if you look at the best of our batteries in the current age, it is a dud weighing around maybe 110 kgs, which is almost 100 times more, right? 100 or even more than that. And it occupies more space. It occupies around 48 or 50 liters of space in the car, and gives very less of what say density in terms of power and energy. So in spite of that, right, it's almost around yeah, maybe 10 times maybe disadvantaged. If you see the cost, it's almost the same because the cost of electricity is lesser, right? So that is the takeaway which you need to have, that a battery is not the best of the things because it's heavy, and it cannot deliver a huge instantaneous power, and it occupies a lot of space. Now, having said that, at a system level, why would you still prefer a battery, right? Now, what is the difference in this energy efficiency between a battery operated vehicle and a conventional maybe this IC driven vehicle? Now, we call it well to wheel, right? Well to wheel is what we call it. So, in the case of a conventional vehicle, it is well to tank. and tank to wheels. And here it is well to wall and wall to wheels in the case of electric vehicles. So this is overall efficiency, if you see, um, for a conventional fuel, maybe diesel or petrol, generation is around 33%, then transmission is this is quite efficient, and then when it comes to the vehicle is where we lose the efficiency, right? So that is where we get a this thing overall of around 24% as the same as uh, thing, and then you see the weight and the one below the thing is around 80% to actually generate your electricity and transmit it, around 20% to this thing. So we have uh, a kind of this overall gain of around 10% in the uh, for this electric vehicles. So that is where the difference is between this thing electric vehicle and this thing. The margin is just 10%, and my whole argument is if the margin is just 10%, if you do a hybrid, you get a 10 to 14%. So the this thing hybrid is as good as a pure electric. So yeah, so that's a different a debate which I normally try to what to say kindle as a thought. So coming back to our energy storage, we have a set of batteries and chemistries which have come up. The latest among the lot is the lithium, maybe ion batteries, which is in multiple forms. You have the this NMC. You also have the lithium ferrous phosphate batteries, which are quite good in terms of the this energy density and the specific power density. So delivery wise, that is good. So they're getting much lighter. If you see the lead acid batteries, which is normally used for a 12 hours source in the car, it's quite heavy, right? Yeah, that's quite heavy in voluminous. And what we find in the this EVs is a very light kind of battery, though they are still heavy, but they're much what's comparatively lighter than the nickel, cadmium, and the lead acid batteries. So they're getting lighter and they're getting more efficient in terms of power delivery, right? So and what we say hybrid batteries are coming up, and the metal air batteries are coming up. What is very recent is the aluminum this air batteries which are coming up, which are coming up, which is quite promising, but for the specific power density which is quite low. The second what's a crucial component is the this thing, electric machine, and we have two kinds of machines. Just to give you a brief what's it yeah a kind of overview, we have DC motors and AC motors. So you will find some terminology known as induction motors and the PMSM motor, that is permanent magnet synchronous yeah, motors. Some motors are synchronous, some motors are non-synchronous, some motors are AC, some motors are DC. So there's a whole lot of motors, and I've tried to picturize it in such a way that you can kind of understand that each motor has its own application in this EV HEV space. And you can see for the heavy vehicles and for those vehicles, the Teslas and the Volvos and the more powerful vehicles, you use maybe either the PMSM or the induction motors. And for the smaller vehicles, we use the kind of BLDC motors and maybe switched reluctance motor. But switched reluctance motors are not all that popular. We are also having a new pedigree of motors which are basically hybrid motors, which is coming up. So yeah, that's always prone to change and research. and some of them are basically advantages for India, and some may not be. If you see the left side, once you need the permanent magnets, you need to go abroad to get the rare earth materials. And if you can just do with windings, then we have that in abundance in India. So the right side is more India, what to say, benefit, uh, maybe beneficial, like if we have homegrown motors, and the left is more if you want to go for rare earths, because they need permanent magnets. And basically, when we come to the software part of it, we have the battery management systems, which I will not dwell too much into. They manage the what's a power delivery by actually yeah, telling about the what's a temperature and the what is a voltage in each cell of the battery, which I'm sure that you might have heard during your previous sessions. And yeah, this is something which might not be that also focused for a mechanical engineering let's say this in audience. So it just to give you an idea that there is something apart from the battery which is essential for the management of the battery, which is known as the battery management system. And without this, we'll not be able to do it because it's quite risky. The lithium-ion batteries, as you know, is very what's a sensitive towards the temperature, and they cannot operate beyond maybe 50 degrees um, Celsius, which is and after that it is prone to explosion and all this. So you might have heard maybe the cell phones itself. You might have heard that it had a what to say burst, it exploded. So that's because of a kind of overheating and the battery management systems not being very efficient. So that has a significance, but with the scope, I do not keep it for this presentation. And what I will now focus in the next 15 minutes to um, uh, uh, maybe of the presentation is basically what is the vehicle control. So vehicle control is the most significant part to actually tell you that you have to do a lot of mode switching, lot of algorithms, lot of controls in order to get the best from your what is a powertrain. So as a high level block, you have uh, you have a vehicle controller, which we call as VCU in most of the vehicle maybe terminologies. And yeah, that has control on the brake control unit, and it also it controls your motor and the torque delivery to your IC engine in the front. Or yeah, so you have plenty of controls from that aspect, which is basically a more of a supervisory in nature and at a high level at the vehicle, which actually takes inputs like the maybe the brake pedal and the acceleration pedal, and we have sensors at the wheels. We have also the mm, maybe the saying inertial sensors and all those in the vehicles. Maybe at least in the modern vehicles which are equipped with the saying ESPs, right? So these are something which will be used, and this is where the whole intelligence of the vehicle will reside, and it is known as the what's it vehicle control unit. And as this thing, energy management, what we try to do is you can see that you have multiple modes here, right? So we have this thing, acceleration yeah, curve, which is the orange one for the vehicle, which you can see, which is marked with arrow marks, and it peaks, and then yeah, once you have reached a particular speed, you begin to cruise, you reduce your acceleration, right? And then when you want to brake, you then decelerate, and you will see a maybe sinusoid kind of thing which goes down, right? And so this is how acceleration and deceleration happens. A deceleration through braking and acceleration through pressing the throttle, right? And you see the blue filled one, and you have the red what's the curves. So what is done in the hybrid is for the low end torque and for the low end performance where this engine is not very optimal, right? We would rather go with the battery, with the battery power from yeah, for the motor, and we will accelerate through the battery. And once engine gets into the more efficient, maybe at the speeds above 40 or something, yeah, like that, whether this engine is more efficient because they have this thing RPM to torque, right? So at the most efficient a point of the BSFC curve, right? So we would switch back to the engine, and we will reduce the usage of the battery. So this is the whole idea, and we can regenerate the green shaded portions, or to indicate that we will be able to regenerate or store excess energy into the battery at this. So while cruising, here the this thing horizontal yeah, kind of orange and the red says that the vehicle is cruising, and engine is at the most efficient what to say operating point. So we will be charging the batteries. So this is the whole concept of energy management here. And while braking, here on the right, if you see, you will be you'll be charging the battery. So yeah, this is basically through the motor that you charge the battery, where the motor acts like a generator. That is, it's the this thing opposite of for traction. For traction, the battery power goes into the motor and it rotates the shaft. While braking, the shaft has plenty of what is it, load, and that rotates the what is a motor's a rotor, and and uh, and you produce this electric current, which is stored into the battery. So battery acts as the load. Okay, so this is the whole concept of energy management, and we have plenty of driving modes here. So in the blue, at low speeds before this engine came on, we would have had a pure electric mode where the battery is consumed, and there is a hybrid mode till the what's a blue shade ended, right, in the top. So that is known as the hybrid mode. And then you had a pure IC mode where your orange line and red line were say horizontal, and you would have been cruising there. So we have some kind of maybe storage of excess energy, and and in the negative side of the graph, you have the deceleration wherein we would have had reach. So this is the whole concept. If you have to do any kind of control and algorithms here, it's on this. So what are the objectives of energy management? So basically the objectives are, yeah, you have regulations, you have a limited size of the battery, so you have to prolong the lifetime of the battery by charging and what's it, discharging very carefully. You must not charge more, or you must not charge very rapidly. At the same time, you must not discharge very rapidly. You must not discharge more than what is required. You must not have a deep discharge, and you have a lot of yeah, constraints from the battery. You have a lot of requirements to reduce the what we say maybe operational cost of the vehicle, increase the fuel the thing efficiency, and then you have plenty of things on reducing the thing emissions, which is guided by your what's the regulations like BS6 and the cafe norms, and also improve the drivability. So it is multi-objective. So you see that I bring a terminology known as multi-objective. So how is it? Yeah, basically there, right? We have certain things known as the control states, and some of the things known as the output states. Now, what are we trying to control? So we are trying to control the power, right? So we are saying that, yeah, don't power up the kind of IC engine at low speeds. So we are trying to control the torque of the IC engine. You might switch it on, might not switch it on, but you are going to control it. So 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 that becomes a control state, right? You are trying to control the torque of the engine, right? At the same time, you are also trying to control the torque of the motor. You are going to say, let motor have more delivery of power, and you are also, yeah, managing your transmission, changing gears, shifting gears, though automatically or maybe not. So you are doing plenty of things. So we are putting the engine into a particular, what say, maybe mode of operation, and the motor in a particular mode of operation, and at the same time changing the gears, maybe changing the transmission, and we are responding to the driver's demand of more power or less power or braking or whatever, right? And what we come up as maybe outputs is basically fuel economy and the speed which is required and all those stuff. So yeah, this is the top level view of how you will do a energy management. So we are getting into how to do it. So we were focusing on what to do, and then we were saying why to do, and now we're talking about how to do it. So just to take you further down into the mess. So what I'll tell you is, you're going to have some kind of, what's a control strategy, which is known as energy management strategy. Okay, which takes inputs from a battery, takes input of your driver, who says that now accelerate, now stop, or whatever, right? So the driver gives you the command, and we have to break it down as a torque, maybe request to the what we say, the motor or the engine, and of course we should also command the gear on the transmission, right? So this is the whole requirement or the task of the this energy management strategy. Okay, and this is the it makes a huge difference if we don't, yeah, do it in a very optimal way. So you have the, maybe you also have the regenerative braking and all this stuff in this. And moving on, we have two modes which, yeah, and not to scare you with this block diagram. This is more to say that we have two modes wherein you have a charge depletion mode and a charge sustaining mode in a battery. So now say you have full power in your mobile phones, right? Yeah, you continue to browse very fast, and you'll be browsing and yeah, maybe exhausting the power very liberally, right? But when you have only 20% power, you will get into a conservation mode and say that, okay, let me conserve power because I have to make the cell phone power last till the night, till I get my hands on a charger, right? So that is the same mechanism here. You call it charge depletion mode and a charge sustaining mode. When you are flush with charge, you say that you consume it, well and good. You just give the driver whatever he needs. And in a charge sustaining mode, you say that, boss, I am out of charge, so you use me carefully, right? So that is the whole thing. And this adds a different dimension to controls here, right? So you have to very carefully monitor the battery charge. You must see what is the power required on the wheel. Is does the driver needs that much power that he's demanding? or is he just doing it for fun? And if he's doing it for fun, just allow it one or twice, well, maybe once or twice, and then say, boss, this is it. So that kind of mode control strategy is required. So this is one of the strategies which is required, which makes a huge difference. And this one is more to tell you what you can do. So because there is no kind of limits. You can go to some kind of integrated energy management system wherein you take a lot of information from the road. You have GPS, you have maybe global this thing information systems. You have this thing emerging technologies like V2X, V2V, vehicle to infrastructure, vehicle to pedestrian, vehicle to grid or whatever, right? So you have plenty of such what is it data, because there's this age of data. So you can go to a learning based control, or you can do a simple rule based if then else control, or a fuzzy logic control. And you can also do a very academic optimization based. You have online optimization, and you also have offline optimization. Offline optimization is like genetic algorithms and all those, and online is more of maybe model predictive control and all these kind of algorithms, which is a huge topic for research, which hopefully if I get to meet you guys directly sometime, we can get well into this in each point of that, which is a very huge topic. So this is the this thing emerging what we say tech here, which you guys can definitely spend a lot of maybe research and effort in this. Okay, so see, having talked about the this thing, energy management, there are certain other things that is essential in this thing EV and HEV in general. We have a lot of challenges in the thermal management. We'll see that battery heats up, we have to cool it, we have to maybe either liquid cool it, or we have to air cool it with our air conditioner and all this. So you have a lot of those challenges as well. And uh, we have challenges post this COVID because of the supply chain. You would have heard in news that we don't have too much of this thing imports possible during this time. So yeah, supply chain. Unfortunately, we don't have the batteries are basically from China, and the motors also because of the permanent magnet. If we don't have rare earths in India, so that becomes a challenge unless we go for induction motors, which which are copper based, right? So this is a challenge. And for EV, there is an infrastructure is a challenge. Yeah, swapping is an option. We have to scale up our infrastructure, which may not happen in the next 5 years. It may take 5 years to this thing. But EV and HEV pose a huge what's the opportunity for us to invest our what's say this effort to focus on this. And one such opportunity is to improve the performance of the car. For those who are uh, what's a car enthusiast like me, or we'll find that this thing EV is better than the best of the normal ICE this engine cars. Um, yeah, based on the performance, it's much quicker, and it has more torque than what the what's the road itself can handle. And of course, it has plenty of opportunities. We don't have a credible hybrid, a full plug-in hybrid, which is affordable in India. So that's a work in progress, and Mahindra is also working towards that. I guess, and so we'll think. And finally, to conclude my talk, if you see which one is better, it is a very tough call, because hybrid inherently is very complex. You have two powertrains. You would have seen the this thing energy management strategies, which are very complex. though it's very yeah, challenging and very what's it, fruitful to yeah, maybe work on that. It's quite challenging and quite complex, and your transmission becomes extremely complex. You may have two transmissions at some time, maybe sometimes for some configurations. And yeah, your whole thing is complex. The vehicle is heavier and all this, but you have another what's the aspects where you can meet the regulations of the maybe this thing FE and whatever what's a target and regulation. So that is what's it, it's made possible if it is a hybrid. And at this end of the day, we can't have all electric because yeah, just imagine the amount of power. Say one car, uh, one typical electric car has a 20 kilowatt hour battery. So that is around 20 kilowatt hour of what say this energy of electricity. If you have a locality full driving this electric cars, then just imagine, is it sustainable? It may not be sustainable. So you will have to look at multiple powertrains. And for now, we might have to live with the hybrids for the next decade till we find a way for the this EVs. And of course, we are stacked up with plenty of challenges. It's a very brutal market. Yeah, first to market, faster to market, and we have constraints that okay, this is a new technology to do, and not many OEMs have done that. A very complicated E&E, and and your HEVs are the foundation stones for your ADAS. That is for the maybe autonomous driving, which is a long way in India. So I leave you with some pictures from our lab in Mahindra. So we have a rapid prototyping lab based on D space in Mahindra, in which we develop a lot of prototypes. And this is one of the prototypes. See, unfortunately, I don't. Are you able to see the video?
Yes, sir.
Yeah, so on the left is our rig. So you would see some of the saying hardware here, which we develop in the rig, and then we put it in the vehicle. So this was one of the prototype vehicles which was developed in house, and you know which vehicle it is, right? So I'm not supposed to say that. So yeah, so this is some of the pictures, and the future looks good. And you are this thing HEV business and EV business combined is going to be around 4.8 billion dollar by 2025. So yeah, with this I'll just wind up, and then let's have some interactions if we have time. So yeah, we are looking at the practicality, simplicity, and the current trends are towards this thing electrified. But in the this interim, we have a decade of maybe transition to take, wherein hybrid takes some kind of significance. With that, I conclude my presentation. I'll be open to any short questions if we have the time. I'm sorry for not being able to do the what, what is a slideshow.
It's okay, sir. It was clearly visible, no issues with the slide, and you are on time. Sir, I have few queries. If I want to start like a charging station, what could be the ideal time? And so that was my query.
Well, yeah, charging station is yeah. This is very this thing interesting. I've not had such a question from the places where I've kind of presented. It's a very forward-looking idea to get into the charging station business. And as entrepreneurs, you guys can maybe as academics, where you have a huge pool of talent and maybe what do we say, manpower and energy, you can definitely look at getting into this business, because that is the weakest link. The if there's something which is preventing our maybe move to hybrid and this thing EVs, that is the charging stations. We don't have charging stations. Even at home, we can just give a 15 amps socket, which is barely this thing enough for you to charge a vehicle, which has a battery size of around 40 kilowatt hour, right? Your Tata Nexon is a 40 kilowatt hour battery. So so you are going to take this thing ages, maybe if not ages, at least a sufficient part of your day to charge it at home. So so definitely charging stations infrastructure is the main link, and the and and maybe the what was the weakest link as of now in the whole this thing EV story. So we have to have, and if I say in terms of distance, what I'd say is it should be there every maybe 100 kilometers. We should have a proper EV station, maybe this EV charging station, right? So this thing, as you break for coffee, you should be able to have maybe charging stations, yeah, wherein you can enjoy the coffee while the car is getting charged, and you drive up to that.
Uh, Sir, I had one more query. On behalf of our students, many students are in this meeting, what are the key area for the students to look forward in hybrid vehicle for their final year projects? Like,
Um, I had one slide. If I can go back to that, um, it was um, yeah, this one. You're able to see my screen.
yes, sir, it is visible.
So this fellow is the most challenging one. You can do something like an optimization based algorithm, which is um, right, it is based on very hardcore, what we say, maybe optimization algorithms, which you'll have to run in tools such as MATLAB Simulink, and maybe 1D maybe simulation tools, if you have something like Dynafor or a car maker, or a car sim or something like that, uh, yeah, without a vehicle. And if you have a vehicle, if you put this into a vehicle, and if you can actually maybe test it in a vehicle, it would be a kind of game changer. Which for the current thing, we have only rule based algorithms. If or else, that is, you have a few rules, and that is all we have. We don't have what we say, a proper sophisticated, what to say, this an optimization based, what's a control. And learning based is, of course, the next generation. I don't see that happening very soon in India, but that is something for the future, for the academics to take it forward. From the hardware, that is from the maybe from the vehicle layout, a scheme of things, um, the platform itself is prone to changes, right? So you could look at some kind of a transmission, maybe design or something like that, which will give more flexibility. Maybe example for a P4 hybrid, right, which we were talking about. The P4 hybrid will have, which now typically has a single speed transmission. But if you have a multiple speed, what's a transmission, then there is plenty of scope for improving the efficiency of your what to say, motor. So that is one huge topic at a very hands-on ground level. That if you can work on the transmission for EVs and HEVs, that is a huge thing, because you will do away with the clutch at the front, and clutch is basically prone to a lot of performance and maintenance, and a lot of issues. So yeah, transmissions here is a huge thing. if you have a multiple maybe speed transmission, maybe a 2-speed or a 3-speed a transmission, we would actually operate the motor at the most efficient range.
Uh,
So these two are the my favorite subjects where you can spend all your life on.
uh, Thank you, sir. With this, we have come to an end. I sincerely thank Dr. Deepak Paul for his valuable information on energy management control strategies of HEV, especially on the topics like energy efficiency in both hybrid and electric mode, energy management strategies, comparison between conventional and hybrid mode, and especially the PPT, sir, that it was a really good, like it was all about pictorial representation. So we enjoyed your session and it was very informative. So thank you for your time, sir. On behalf of Mite fraternity, I thank for your valuable time, sir.
Yeah, thank you. Thank you, Arvind, and thank you, Professor, for inviting me for the session. And I'm glad that I've had a nice time. And I wish you all the best for the remaining of this program. And yeah, good luck. And
Thank you,
see
sir.
you. Yeah. Bye.
Okay. So, dear participant, I will post the attendance link, and students are informed to not to fill the link, and we will start our next session at 11:30. Please log in at the exact time. Thank you, one and all.